Yeah, we've got a bunch of people that have been interested in going with either solar and or wind, and so we wanted to reach out to you to kind of give us a little backstory on this and what we provide. So I think everybody that's here has been thinking about, you know, how we can reduce our energy costs and be more environmentally responsible. So that's what we're hoping to get some info on that.
Yeah.
All right, well, thank you very much. So for my introduction, you will see at the top of the screen, the title says DWT, which is Ducted Wind Turbines, our company, distributed wind energy. And distributed wind energy means energy produced at the point of use, which we believe, and which is backed up by the National Renewable Energy Lab in Boulder, Colorado, that is absolutely critical to our environment and to our goals to the electrification of everything. And I'll get more into that in a minute, but that's why we titled it this way, because our turbines are not utility grade turbines. Our turbines are made to work behind the grid, to offset the cost of retail energy, and to provide energy security, independence, and a hedge against rising energy prices, and they will rise. So just to go to the next slide here. There we go. Can I go to the next slide? There we go. So the problem we solve is electricity prices are increasing. The grid is becoming unstable. We see stories about this all the time. Security and resiliency are not achieved by solar alone. Why is that? Well, because solar only works 4 to 6 hours a day. And if you don't have a huge battery system, it's not that efficient. And many of the places that we're targeting, Caribbean islands, places in Africa that don't, and South America that don't have any power, northern Canada right now, these are places that desperately need a solution that is point of use and distributed energy. And so a economical, easy to erect and easy to assemble small wind turbine is absolutely vital to solving those problems. So a little bit about our turbine. It is lightweight. It's about 550 pounds. That's to the that's right here to the base of the slew bearing, to the base of the pole. It's easy to assemble. It's easy to ship and install. It's designed for snow, high winds, all kinds of different weather, salt spray, anything that you need, and it's economically viable and it's high performance, which means that it takes in more wind, and the wind comes in from the narrow side. I'll get more to that about that in a minute. But it comes in from the narrow side and goes out the large side. So it doesn't act like a funnel. It's kind of the reverse of that. It's called a lift-driven turbine, and I'll talk about that in a minute. It's manufactured here in the US. Some of the electronic components are manufactured in Spain and Italy and Ireland. But other than that, all of the other metal parts and the blades and everything else are manufactured here in the US. We believe it's extremely highly reliable and highly efficient. We've had them up for 4 years right now. First one we put up was in April of 2019. It's still up and running, still operational, and no problems, even in 70-mile-an-hour winds. So we are pretty confident in the design of this turbine. So the next question is, why are we different from other turbines? Well, we wrap this airplane wing. This is like an airplane wing here, this duct section, around the turbine. And when that happens, you capture about twice as much air as you would with an open rotor turbine. So if you had an open rotor turbine, all this air would be coming in laterally. But with an airplane wing around it, like I said, it's a lift-driven turbine, just like an airplane wing. We're going to capture about twice as much air, which comes in the narrow side and goes out the wide side. This is a patented technology, not because it has a duct, because duct turbines have been around since 1920, but because of the design of the duct, because of this airfoil design of the duct, and because of where we place the rotor in the duct, which is way back here in the throat of the duct, as opposed to right in the front, which is where most companies have done that. And so we have an exclusive license on this patent from Clarkson University, and it does put out not quite twice, but pretty close to twice the power of a similar sized open rotor turbine. So our turbine is 12 feet in diameter. If you wanted a turbine that would produce the same power as ours, it would have to be about 24 feet in diameter. We have lots of applications and uses. We've built this to be extremely flexible and to be able to be grid tied, used off grid. We augment solar. It can be ground and rooftop mounted. We use it for nanogrids, for telecom, for electric vehicle charging stations, for remote power, where electricity is expensive and unreliable and non-existent. That's our mantra. That's where we want to put these. And unfortunately, in New York State, electricity is becoming more and more expensive, not because of the rate that you see on your electricity bill from National Grid or NYSEG or whoever your provider is, but because of demand charges, because of peak charges, because of all these little charges that are slowly working their way into your electric bill. And so we totally believe that electricity independence, electricity reliance on your own electricity is the best way to go. And so we're reducing the cost, but we're also providing electricity independence. And there are these problems, as I said. The electrification of everything creates grid stress. Grid was built for balance and control. So you've got a coal-fired plant over here, and you got a gas-fired plant over here, and they're completely under your control. And so you can raise one, and you can balance them, and that's how the grid was built. But the problem is solar and wind cannot be controlled. And so if we go to total solar and wind, we're in big trouble, because we need all kinds of different controls on the grid in order to make this work. And so this is why the grid is vulnerable and fragile at this point in time. And you'll see, and it takes 10 years to put in a new transmission line. This doesn't happen overnight. And so the focus has been primarily on, let's put, tons of turbines out in the middle of the ocean. Let's put lots of solar on every spare acre of, tillable farmland we can in upstate New York. Okay, that's good to a point, but the problem is you're not addressing demand and distribution. And when you don't address that, you have a problem. And so that's why we believe distributed energy, point of use energy is really, really important. So the distributed wind market, and this is NREL, this is National Renewable Energy Lab. They say there's a potential for distributed wind in the US of 1.4 thousand gigawatts. That is about half of our country's consumption of power right now. And so it's a lot. And that's just wind. That's just small wind. So, and when I say small wind, I don't just mean our turbine. I mean anything from our turbine is a 3.5 kilowatt turbine. I mean anything from 1 kilowatt up to maybe 50 kilowatts. So these are smaller turbines, not the big giant ones you see in wind farms, but anything that goes up maybe 40 to 100 feet in the air, something like that. So we have a huge potential, and we have over 40 gigawatts of potential in each of the top 10 states. So here are some of our installations right now. It shows you some of the options that we have. We've done ballasted rooftop on a flat roof for an industrial building. We've done a guide rooftop. That's on the Clarkson. That was our first installation, actually, on the roof of the TAC building on the Clarkson campus. We can do a concrete foundation monopole, or we can do a ballasted monopole as well. So this ballasted monopole is basically sitting right on the ground. It is a box, a metal box filled with concrete or gravel. And that works extremely well. And so when you think about places like, well, we can't put a concrete foundation in a village in, Peru or in Africa or up in the tundra of Canada, we can certainly do a ballasted monopole and fill it with something heavy. So here are some of our installations. This is the Clarkson University campus. I just told you about that. This is a guide monopole. That means it has guide wires to it, and it's just sitting on the roof. It's not penetrating the roof or anything like that. So the guide wires take up all of the load of the turbine. This is a New York State farm in Essex County and in the Adirondack Park. This is an 8-meter tower on a ballasted base. And we installed this, I think, sometime last fall. This is Asgard Farm and Dairy, which was one of our first sold installations. This is up in Ausable Forks, New York. David Brunner is the owner of Asgard Farm and Dairy, and his wife Rhonda. And we've had that one up for 3 years now, no problems at all. This is the Clarkson wind test site. This is actually a 12-meter tower, so it's a little bit higher. But we had it up to 12 meters so we could actually test the wind. And there used to be a wind test site in Tully, New York, not far from where I live, but that is a little antiquated and it's been closed down now. So we had to build our own. This is SUNY Potsdam. We have a turbine there, which we put up, I think, about a year ago, last spring. SUNY Canton, we have 3 turbines going up there. We thought in Q1, they're actually going up in Q3. They are all ready to go right now. They have the foundations done, the towers are there, and our turbines will be up this quarter. We have one as a retrofit to an older turbine in Heiberg Forest and at SUNY ESF down in Syracuse, New York, or actually it's in Tully, and that'll be going up again this fall. And the Wild Center in Tupper Lake is putting up one of our turbines on an 8-meter tower and a ballasted base, and that will be going up this fall as well. So we like to think ahead. We like to think what could be. And so here are some of the renderings that we have to try and inspire people to use their imagination, think outside the box, think of what could be. And we always like to say, people say to us, well, should I have solar or wind? And we always say, yes, you should. You should have solar and wind. Solar works better in the summer. Solar works better during the daytime when there's no wind. Wind works better at nighttime in the wintertime and spring and fall time. So they are extremely complementary. We do not see ourselves as a competitor to solar. We see ourselves as a complement to solar. Another rendering, we thought, well, the new Apple Green rest areas that are going in along the thruway, what a great place to put up a couple of our turbines. We've met with Kathy Hochul's office. We've met with Eric Adams' office in New York City, and we're trying to get to the New York State Department of Transportation so that we can get some of our turbines up along these areas to try and alleviate the stress on the grid that's going to be created by people pulling into these rest areas and charging up their Teslas or their Leafs or whatever electric vehicle they have, their Ford Lightning for that matter. And we think that we know that this is an absolute necessity. If we're going to electrify everything, then we've got to generate electricity everywhere we possibly can. Another rendering of 41 New York City municipal parking garages. This was something we showed to Kathy Hochul when we were down there a little over a year ago in her office. They're investing $420 million for an all-electric fleet of buses, but you've got to charge those buses. You got to charge them every day, every night, and there's no better way to augment what the grid can give you than to create on-site wind and solar energy. This is our little trailer that we built. We built this as a way to take our turbine into trade shows, into the New York State Innovation Summit, which is you see here. We were there in Buffalo last year. But also we called it our solar wind emergency power trailer, SWEPT. And then we built an entire proposal around this, which we continue to shop around to FEMA, to the DOD, to the federal government, and to different state governments, in an effort to try and entice an agency to fund this into full field-ready use prototype. And we haven't been able to do that yet, but we're still working on it. But this has actually been kind of disassembled now, but we can assemble this for other reasons. Now, one of the things we did assemble it for was at the FISU World University Games in Lake Placid. Our little trailer over here, and when you just saw in the last with the solar and the wind, powered the cauldron for the FISU World University Games for 12 days with all renewable energy. And so that was kind of cool. And we obtained a little bit of exposure and a little bit of press out of that, which was great. But we have a long way to go. So this is our team. Dan Value, the guy here on the far left, is our chief engineer extraordinaire. This guy can do anything. He's designed this turbine. Just to give you an example, there's a nose cone right up here on the tip of this turbine. And we went out for bids on that nose cone, and we found that to get it injection molded by a company would cost about $3,500 a piece. And so Dan said, I can build a 3D printer for $1,200. And he did. And now we 3D print our own nose cones for about $25 each. Ken Visser is the heart and soul of the company. He's the guy that designed this turbine. This came out of his lab. He started this effort in 2010, back when there were lots and lots of garbage turbines out on the marketplace, because anybody can make something go around, but making it actually produce electricity at a reasonable rate, economical rate, is very, very difficult. So he's a professor of aeronautics and one of the leading experts in the world as far as aeronautical engineering with regard to wind turbines. Paul Pavone is his partner. Paul and Ken started this company back in 2016. I came on in 2019 as their NYSERDA EIR, entrepreneur in residence and mentor. And I've been, and they asked me to come on board as their CEO in 2020, which I did. Ed Paparelli has installed turbines all over the country, all over the world for that matter, in Uruguay and the Eiffel Tower, all of our competitors' turbines. So that is a wealth of information, and he is the best guy in the field I've ever seen in my life. So here's where we are. We've raised about $90,000, and this is kind of a little bit of an investor pitch, but it's also the sales pitch too. We've raised about $400,000 in different grants, NYSERDA grants, NREL grants, and about $1 million in convertible debt. And we're currently selling turbines. We've gone through our Gen 1, Gen 2 beta prototypes, and now our Gen 3 commercially ready turbine, which we're selling in the marketplace right now, both to commercial and residential customers. And we believe that we absolutely have the right product for the right market at the right time. And that is my presentation. I'd be happy to take any questions.
Solar panels, if you're doing like a multi.
You might have missed the beginning of that. So
Oh.
try that again.
Yeah.
We were muted, so he might have missed the beginning of that.
So you just want to know, because we kind of understood that you were doing both solar and wind.
We don't do both. Well, okay. Let me explain a little bit. Ducted Wind Turbines does not do both solar and wind. We advocate to have both solar and wind, but we do not do solar. Now, we know other companies that do solar, and we have partnered with them. And so we can easily go to one of our installers like Castle Energy, a company out of Cleveland, Ohio, and say, who have installed our turbines, and say, this customer would like solar and wind, and they like a full, a full solution for their home or their business. And we can absolutely provide that to you.
Now,
So you would actually do the installation of the solar panels then?
We Castle, our partner, they are our installation partner. They do the installation.
I'm sorry, you broke up there. Is Castleton? Yeah. Okay. But you said they're out of where? Cleveland?
Yeah.
So what would be the cost of any of this?
Turbine's cost, our retail cost for the turbine is $19,500. That is for the turbine and all the downstream electronics. The tower and the installation are not included because that varies all over the place. It depends on whether if you want a guide monopole in the middle of your yard and you don't mind wires coming down from it, that's way less expensive than a tilting monopole, which is what we do most of the time. And then it depends on what you want for a foundation: concrete foundation, ballasted foundation. A rooftop mounting system can be $5,000. A fully, concrete foundation in the ground with a bolt cage in it, with a tower on it, and a tilting tower that comes up, that can be as much as $15,000. So the installation and the tower can range anywhere from, say, $4,000 to $20,000.
Is the commercial size the same as residential size? Is this a one size?
We only have one size, and that's our 3.5 kilowatt 3-meter turbine at this point in time.
And is it hooked up to some sort of battery that stores the energy when the wind's not blowing?
It can be. Our turbines are meant to be grid tied, so they will offset the cost of your electricity. If a customer wants to invest in a battery system, our inverter that we use will do either one. It'll put power back out on the grid, or it will charge a battery.
Now, are some of the grants, like from NYSERDA and other, like federal grants, do they apply to these installations or the material itself?
There is a 30% federal tax credit that's in the IRA that was just passed. That's actually increased to 40% because we are a U.S. made company. We make our turbines in the US. So there's a 40% tax credit, which means if you owe $10,000 in taxes, you won't have to pay 4,000 of it. Or no, 40% of the cost of the turbine. So I'm sorry about that.
So generally, when you're putting these in, is it folks where they already have a battery bank system or something?
No, nobody has a battery bank system. Very few people do. We can connect to a battery bank system. Obviously, if we're selling energy security and energy resiliency, you need a battery, because if your power goes down, if your grid goes down, you're not going to have any electricity from your turbine, from your solar panels. I have solar panels on my house right now. And when the grid goes down, I do not have power because I do not have battery system. So a battery system is absolutely the buffer between you and the grid.
Have you done any municipal installs, like for small towns or anything like that?
We have not yet because, again, it's not a utility grade turbine. It's more of a microgrid, nanogrid, residential, small commercial piece of equipment. So it's a machine that will put out 5,000 to 8,000 kilowatt hours of power a year. Now, the average American household uses 11 to 12,000 kilowatt hours per year. So we can provide half to 2/3 or maybe even 3/4 of the power of the average American home.
Like we were talking about maybe doing some things for our school that is now defunct, but we're using it as a workspace, and we have our task force there. And possibly doing a combination of wind and solar.
You got a charging station there too.
Right. That would be great. But also even for the town buildings here, if we had something, available for them to utilize. We're working on some grants. We already have one $5,000 grant, and we've got some more grants coming. As soon as we complete them, we'll be getting more checks for $5,000. So would like this, I don't know if you're familiar at all with the Inlet town hall with,
I'm very familiar. We spend a lot of time up in the Adirondack, so yes.
so would it be enough to power the building here, for example?
I don't know what I'd have to look at your power rating and what you're running there. I wouldn't know until I saw what your load is.
Right, okay.
What's your general amount of time it takes to install? So let's say you move forward to the project and you know, you're doing let's say a rooftop ballasted system. You know, is it a pretty long install process or is it pretty relatively short?
A rooftop ballasted install system would take we usually keep 3 to 5 turbines in stock at any time. And so I would say probably 8 to 10 weeks at most.
And are there any bottlenecks at all with working with like National Grid or NYSEG or anything like that? Or have they been pretty reasonable in letting you
They've
tap
been
in?
extremely easy to work with. So we work with both NYSEG and National Grid, no problems.
And with the trees around here, and the so the APA regs as far as height and things like that, the pictures you were showing, they seem to be in pretty open areas. Have you run into any issues with, you know, trees or blocking airflow or anything like that?
That can be an issue, yes. And so we would have to come and look at your particular area. I'm familiar with the inlet area, but I also know you have wind coming down through that lake system, through the Fulton Lake system, pretty good. So I'd have to we'd have to look at that. We do not do wind studies or anything like that because it's just too small of a piece of equipment to do that with. If you were putting in a 1 megawatt turbine, then that was going to cost $1 million. Then you'd want to do a wind study or something like that. But most of this is just objectively and subjectively looked at, and we obtain the data from National Renewable Energy Lab has really good wind maps of the country, and we can focus down in pretty closely to what your average wind speed is. And then we'd have to look at the exact location of where you'd like to put the turbine. And we will tell you, yes, that's a good location, or no, it's not going to work here.
How far away can the turbine be from the point of need?
We like to keep it within, 300-400 feet, 500 feet at most, just because it's a lot to run wire and conduit. So, we offer 100 feet of wiring with our turbine. Anything beyond that, we ask the customer to cover because some of these runs could be extremely long, and we just don't have the wherewithal unless we put that into the bid, into the proposal, in order to cover the cost of that run.
Is it dropping efficiency the further you get away from the turbine as well? Are you losing power over the length of run?
Not that, no, not appreciably at all. No, not that much.
Stupid question. Does it only come in one color?
Nope, we can make it any color you want.
I was gonna say, I could see a ton of like locals being like, what's the color?
You want it black, you want it green, you want to put the Inlet town decal on that, we can do that too.
They're gonna want mossy oak breakup up there.
How far out as far as do you have like a backlog at all as far as like production or install? I mean, are you all?
We've got 8 installs going in right now, and so we don't really have a sales backlog. All those are staged at our shop in Potsdam, New York, and they're all ready to go. And so we don't really have a huge backlog. We are aggressively looking for sales right now.
Is there any limitations on when your install season is? I mean, is there like a point in which it's too cold to come up and do installs? Like,
Nope, we've installed in the wintertime, we've installed in the summertime, we can install any time of year. The only problem is if you want a concrete foundation, then digging out the ground and putting that in is going to be a limitation. But that's the only limitation. If you go with a ballasted base, And we can do a ballasted base for an 8 or 12-meter tower. Of course, if you want a 12-meter tower, you're going to have to get a variance with the APA. But the 8-meter tower, the top of our turbine on an 8-meter tower is 39 feet, which is under the 40-foot regulation for the APA. So we're good.
Amy, I don't know if you're there, but any barriers as far as codes or zoning or other things to ask about or consider?
Amy, are you muted?
She might be away.
Sorry, I was muted. No, the 39-foot tower height was one of my concerns, like how high does it have to go in our area to be under that 40-foot threshold? No, it's been a good presentation. I don't have any additional questions.
Have you done much in the residential installation?
We have, yeah. So we've got one. Well, we've got one. The farm in Essex is really a residential installation. Asgard Farm is a commercial farm. We've got two. We've got one residential installation in Potsdam, New York, and we have 2 turbines going into another residential installation in Norwood, which is just a little north of Potsdam this fall. So they are those turbines are already sold, and we're going to be installing them.
Is there any possibility of, if you had a couple houses next door to each other, of being able to power both, or it has to be one individual home?
Nope. We could definitely split our power off to share it between 2 homes.
And that would be the maximum.
Right. So the other thing I need to tell you is that the inverter that we use is a Solarc inverter. The Solarc inverter has 2 channels on it, one for solar and one for wind, or you can use both channels for wind. And so one of our inverters will handle 2 wind turbines or wind and a small solar array.
So one neighbor gets the solar.
Yeah. What about maintenance and upkeep? I mean, once you all install, are you all sort of the people we would call if there was issues or problems, or do you farm
We
that
are
out?
absolutely the people you would call if there were any issues. We have had no issues. We built these turbines to be maintenance free. We greased the slew bearing. There's only 2 moving parts. One is the generator that turns around, and that's a sealed bearing, and the other one is the slew bearing at the top of the tower that turns the turbine into the wind. We have never had a problem with those in 5 years now, and we do not expect to have a problem with them. They should be good for at least 15 to 20 years.
And they automatically will turn to the direction of the wind.
They automatically turn because of the shape of the duct. Yes, they are extremely sensitive, and they will actually align themselves to the wind direction before the rotor starts turning. So like in 2 miles an hour, it'll align itself.
That's what I was going to ask you. What amount of wind? I thought I heard at one point 10 miles an hour.
No, it'll start at like 4 or 5.
Okay.
It's not going to create a lot of energy then. It really gets going at like 8 to 10 miles an hour. And 12 is perfect. It's going to really be whipping then. And it's going to be, it's going to be adjusting itself to the direction of the wind automatically. So, and then as far as higher wind speeds go, our turbine has a 2-stage braking system on it. So that when the winds get up to like 30, 35 miles an hour, it's like tapping the brakes on your car. You want to slow it down a little bit. You want to keep it under control. And then at 40, 45 miles an hour, we shunt it completely, and it'll actually turn off. And we do that electronically and automatically through the system that we built. And the reason for that is we don't want it overspinning and freewheeling and just tearing itself apart.
So there is some computer or software that goes along that controls all this adjustment into the wind and direction and stuff?
There is, and there's also a monitoring system that we have We watch every one of our turbines on a dashboard that we can provide to the customer, and we also watch it ourselves. So we know the production of every one of our turbines. We can inside of our shop up in Potsdam.
You guys.
Is it,
Your dogs are talking.
is it possible to use existing stands, if you will, and sort of like weld, like something that exists already, a cell tower or a,
You mean like an existing tower?
yeah.
That's it may be. So I showed you the Heiberg Forest one that we're doing a retrofit on, but we did an engineering analysis of that to make sure that it could take the loads. What do I mean by loads? I mean the pressure of the wind against the duct and against the turbine itself to make sure that the tower and its guide wires or it's strong enough to withstand that up to about 103 miles an hour. And so we would have to look at the tower that you're talking about and get the engineering drawings from that and then do an analysis.
So if you all were to, let's say we said, yep, ducted wind turbines, we're gonna, we've got a couple people that are in a couple locations are interested. Do you all just do like a sort of a free estimates? Do you come up and do like an engine? Like how in depth is the process to figure out?
We would come down, we would look at the location. We would, and probably Ken would come down from Potsdam because you're pretty close. Ken and Paul, and I might be there as well. And they would come down, they'd look at your location and they'd say, yes, this is a great position for a turbine. We could do a 40-footer here. It's great. Or nah, you really need a 60-footer here. So we're going to have to apply for a variance if you want one. We're going to have to apply for a variance because it's going to have to be a little higher. And then we would provide you with a proposal either way. And that proposal is free of charge. Yes, and you can take it or leave it.
Well, we really appreciate you meeting with us, and if you have any recommendations also for solar companies that are in our area that we might work with as well.
I do, and I can certainly do that. And like I said, we're starting to partner with other solar companies right now because we truly believe that it's called the hybrid solution, solar, wind, batteries, all three legs of the stool is the best way to approach creating energy at the point of use distributed power.
So do you have specific ones that you would suggest?
We do. I don't know the name of them. One of them is up in the upper Adirondacks. And let me talk to Paul about that and I can get back to you, okay?
All right, that would be much appreciated.
Okay.
Okay. All right, well, thank you so much. Really appreciate
You
it.
are more than welcome. It's been my pleasure to have this opportunity to present our company and product to you, and we hope to move forward here.
Okay.
Yeah, we'll share this around, Joe, and hopefully we'll be calling you to have you all come up and take a look at a couple of sites. That's the hope.
Either anytime you want us.
We know there's a property here that maybe has already talked to you. I don't know if I dare mention it, but okay, all right, out there. The Sunset Beach, he's been talking about getting in touch with you, and they have little cottages there and
Yeah.
also a greenhouse.
Yeah, I know where that is. Yep.
Okay,
Yeah.
okay. So I was hoping, he sounded like he was gonna try to make it here tonight, but he hasn't, but we'll definitely pass this on to him.
Yeah, please do.
Very
And
interesting.
like I said, I am 2 hours from Inlet, so I can be up there anytime you need us up there, and it would be no problem talking my wife into coming up there. So,
Well, we'll
Excellent.
send you out in a kayak, okay? Well, or at least your wife will, while you're over there working. That's it.
okay.
All right, thanks,
All right,
Joe. Well,
thank
you
you.
enjoy this beautiful weather.
Thank you so much.
All right. Thank you. You too. Appreciate the opportunity.
Bye-bye.
All right.